Arc length. Okay, we've been finding the degrees of an arc, and now we're going to find its actual length. So we first need a quick reminder of circumference. That's the entire length around a circle. So the way we find circumference is 2 pi r. 2 times pi times the radius, or pi times the diameter. For most things, we use 2 pi r. The other thing we need to know is the total degrees of a circle, and remember that is 360 degrees. So these are the two things that we're going to be using to figure out the length of part of the circumference of a circle. So the first thing we need to do is think about what fraction of the circle is the arc. So on this problem over here, where I'm just going to call it number 1, I have a 60-degree central angle. So its arc is also 60 degrees, because remember that central angles and their arcs are the same degrees. Well, 60 degrees is 60 of the total of 360 degrees. So if I'm thinking about fractions of the circle, that's 60 of 360 degrees, because 360 is the entire circle. If I were to simplify that, I can divide them by 10, I can reduce them both by 6, and that's 1/6. So 60 degrees is 1/6 of the circle. That's going to come in handy in just a little bit. If I have a highlighted circle like on problem number 2, we have to be very careful because this central angle is 120, but what I have highlighted is the major arc on the other side. So if I do 360 minus 120, this is 240 degrees on the other side. So I'm talking about the major arc on the other side. So that is 240 degrees of a 360 degree circle. So I can reduce that. And I can reduce them both by 4, I believe, and I can get a 6/9. Oh, I can reduce it again to 2/3. So I could actually have divided both of them by 12. So that is 2/3 of the circle. So the fraction of the circle is going to come in handy in a second. So let's just say we had this circle right here. It has a radius of 5 meters, and I only want 90 degrees of the circle. Well, first of all, let's figure out the circumference of this circle. Circumference is 2 times pi times the radius, which is 5. So that's going to be a circumference of 10 pi. Now, for the interest of this one, I'm going to make that into a decimal. And I'm going to be using the pi button on my calculator just so that I'm more exact in terms of making sure that my fraction works. So 10 times pi is about 31.42. I'm just going to leave that on my calculator though. Now, what fraction of the circle am I asking for? Because the entire circumference is 31.42. But what I want is only that part of the fraction. Or of the circle. That is 90 degrees of the full 360 degrees of the circle. Well, that, reduced by 10, divide them both by 9, is 1/4 of the circle. So I only want 1/4 of the circumference. So the way I can figure that out is I can do 31.42 times 1/4. Little reminder, all I need to really do is multiply across. That's 31.42 divided by 4. And finding a fourth of something is like dividing it by 4. So if I found a fourth of that, that means that my arc length is about 7.85 meters. So I only found a fourth of my circle. Let's try another one. So on this one, I have a radius of 10 and a central angle of 105. But if you look at what's highlighted, I'm looking for the major arc. So I'm going to go 360 minus 105, and this is 255 degrees. So first, let's figure out the circumference. Let's figure out the entire length around the circle. So that's 2 pi times the radius, which is 10. So that's 20 pi. So if I multiply 20 times pi, I get about 62.83 yards. Okay, so what fraction of the circle do I want? I want 255 degrees of the 360 degree circle. I'm going to reduce my fraction. I'm just telling you right now, you don't have to reduce your fraction. I will show you both directions. If I divided them both by 5, I would get 51 over, come on, my 0 button's not working, 72. So I want a fraction of, oh, I can reduce that by 3 actually. I can reduce that again. 51 divided by 3 is 17. It's that lovely number that looks like it's prime, but it's actually not, and that's 17 over 24. So I want 17/24 of my circumference. So my circumference, again, was 62.83. And I'm going to multiply that by 17 over 24, because I only want 17/24 of my circle. The easiest way to do this, okay, in your calculator, you're going to go 62.83 times 17, so 62.83, times it by 17, and then divide it by 24, because that's in the denominator. And you should get about 44.5 yards. So what we're doing is we are taking, to find the arc length, so this is only part of the circle, we are finding the circumference, which is 2 pi r, and multiplying it by the fraction of the circle that we want. So we're taking the circumference and multiplying it by the degrees over 360. Now, back at that original problem, by the way, if you didn't want to try to figure out what 255 over 360 was reduced, you could have also done 62.83 times 255 over 360. And I want you to try this. In your calculator, I want you to go 62.83 times it by 255, because you're multiplying the tops, and then divide it by 360. You should still get 44.5 yards. So you don't have to reduce your fractions, okay? You don't have to. So this is the formula you're going to be using to find an arc length. You're going to find the whole circumference, and you're going to multiply it by the fraction of the circle that you actually want. So the degrees out of 360. Now I do have one extra problem, because sometimes what you're given is a little bit different. So this one says an arc of 45 degrees has an arc length of 100 pi. What is the radius? So let's think about this. Our equation is the arc length equals the circumference times the degrees over 360. So what do we know? We know the arc length is 100 pi, so I'm going to substitute 100 pi for arc length. We don't know the circumference, but I know the equation for the circumference is 2 pi r. So I just put the circumference as 2 pi r. And I know my degrees, which is 45 over 360. So the only thing I don't actually know is the radius, okay? So let's see if we can figure this out. So first of all, you can cross off the pi's on both sides and not have to worry about those, because you use essentially dividing both sides by pi. So I'm going to have 100 equals, I'm going to multiply the 2 by the 45, just because it's like 2 over 1. So that would make it 90 over 360 times the radius. Well, we can actually reduce 90 over 360, kind of make this problem a little bit more simplified. That's 1/4. And if you have a fraction in front of a variable and you want to solve for it, multiply by the reciprocal. So you end up with a radius of 400. So what is the radius of the circle? It is 400.